All right, so continuing on with our talk about quadratic functions and their properties, and meaning that we're looking at things in terms of the quadratic functions, vertex and axis of symmetry. We have this function here, negative x squared plus 4x, and what we want to do is, of course, graph this function and then figure out things like its vertex, axis of symmetry, and all that good stuff. So the first thing that we want to note is what are the basic properties that we need to extract from this. So if we have y equals negative x squared plus 4x, then notice that a is equal to a negative 1, our b is equal to plus 4, and our c is 0. So from that, if we kind of scroll over here to the left, we see that our h is going to be minus b over 2a, and then our k is going to be 4ac minus b squared all over 4. So we're going to use that information to find out what our h and k are. So here our h is just minus b over 2a, which is a minus 4 divided by 2 times negative 1. So negative times negative is a positive. 4 divided by 2 is 2. So we see here that h is 2. For k, we can use this formula. And so we have 4 times a, which is a negative 1, times c, which is 0, minus b squared, all over 4a. So from there, we know all of this ends up being 0, so we just have a negative 4 squared, which is 16, over negative 4. Negative divided by negative is a positive, and so our answer is a 4. So what we gather from here is that our vertex is going to be at the point 2, 4. So that's what we know. And so what we can do now is we need at least one other point to be able to graph this particular parabola according to the graphing tool that we have. So what we could do is, since we know that our vertex is the point 2, 4, our axis of symmetry is also x equals 2, because it's just x equals whatever the x coordinate is. So we can pick a point either above or below the x value for the axis of symmetry to figure out another point. Here what I could do is I'll just pick the y-intercept. So y-intercept, we let x equal 0. So of course, if we let x equal 0, then everything here goes to 0. So that's a real easy point to pick. So we have the point 0, 0 as a result. And since 0, 0 is 2 units away from the axis of symmetry, we know that this also implies that we have another point 4, 0 as well, since 4, 0 is 2 points horizontally, or 2 units horizontally speaking, away from the point 2, 0, which is on the axis of symmetry. And so I'll reiterate all this again as we draw the graph. So notice here, we'll pick our graphing tool. We'll find our vertex first. So this is the point 2, 4. And then after that, our point 0, 0. And as you see, if you look here, this is the point 4, 0 right there. So you see, by me using the axis of symmetry, I can also guess where other points are as well. So we draw a graph and everything looks good. Again, for our domain, just like how we did in the first video, we know that the domain of any quadratic function is all real numbers. And for the range, since this is the vertex is a maximum point on the graph, we know that the range is going to be as low as negative infinity, and it's going to go as high as the y-coordinate for the vertex, which in this case would be 4. And so You need to put a bracket on the end there to say that 4 is included in that particular range. So here we want to know when the function is increasing. We know it's increasing from negative infinity to, from when x is negative infinity to when x is 2, because the vertex is the maximum point. So we have to answer that in an open interval, as I mentioned in the first video. So we will answer it this way. And then, of course, the function is decreasing from 2 to infinity. So that particular problem is done. So we'll go ahead and move on to the next one, number 5. All right, so our next problem, we want to do the same thing here. We see that we have a function, f of x is x squared minus 6x plus 9. And we want to do same thing, find the vertex, find out where the graph opens up or down, what is vertex, axis of symmetry is, x and y intercepts, so on and so forth. So the first thing that we'll do is we'll identify what our A, B, and C are. So of course our A for this case is 1, our B is a negative 6, and our C is 9. So our H is minus B over 2A. So that would be minus a negative 6 over 2 times 1, which gives us a positive 3, because we know a negative times a negative is a positive. Okay. For our K, we know that's 4AC minus B squared all over 4A. And so we'll go ahead and plug in. Our A is 1, our C is 9, our B squared is a negative, or our B is a negative 6. And so when doing that, we have 36 minus 36. So that ends up giving us 0 over 4, which is 0. So we know that in this case, that our vertex is going to be the point 3, 0. Now, if you were looking at this and saying, hey, we could factor that out, you could also tell that x squared minus 6x plus 9 on its own factors out to x minus 3 times x minus 3, which is just x minus 3 squared. And if we want to append on the understood k there, that would be x minus 3 squared plus 0. So you could also see it that way as well. So we have our vertex here. We just need to find another point on the graph. So we could use the y-intercept again to do that. So I'll clear out some room, and we'll find the y-intercept and then use that to go ahead and graph our function here. All right, so now that we have some space, let's go ahead and find our y-intercept. We find our y-intercept by letting x be 0. So of course, we come here and just plug in 0. You see all the terms go to 0 except for 9. So this also lets us know that we have another point on the graph, which is the point 0, 9. And so, in knowing that, if we have point 3, 0 here and a point 0, 9 here, and we know that the axis of symmetry is the line x equals 3, then of course 3 units away, we should have another point here, 3 units away to the right, x is equal to 6, and y should be 9. So we should have another point 6, 9 as well. So when we go over to our graphing tool, we see that we'll start off with the point 3, 0, and then go to the point 0, 9. And if we look closely here, we see that we also have a point at 5, 6. When x is 6, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So it also crosses there. So we go ahead and check our answer. We'll save and then check our answer and see that everything is good there. Once again, our domain for any quadratic function is all real numbers. So we'll go ahead and answer that. And our range, since the vertex represents a minimum point on the graph now, so now our vertex kind of looks like this. Sorry, our parabola looks like this. And our vertex is down here. Then that lets us know that the range has a minimum y coordinate of 3. So we'll go ahead and put our bracket in 3, and that goes on to infinity, and then of course we put a parenthesis on the infinity part. Oops. So let's see, it didn't like something that we did, so let's figure it out. Oh, sorry. Yeah, this shouldn't be from 3, it should be from 0 to infinity. Because I was looking at x values instead of y values. So, yeah, it should be from 0 to infinity. Excuse me. Yep. All right. So, moving on, the function is increasing on the interval. So, now since our vertex is a minimum point, the function decreases first and then increases. So, the function will be increasing on the second half of it. So that's basically going from 3 to infinity. And then the function will be decreasing on the first half of it, which will be from negative infinity to 3. And so with that, we'll go ahead and move on to the third problem. All right, so for our next problem, we see that we have f of x is minus 2x squared plus 2x minus 1. And so from that, we see that a is equal to negative 2, b is equal to 2, and c is equal to negative 1. So if we go ahead and use the formulas for h and k, we'll see that we come up with the following outcome. So after working out what h and k are, rather, we see that h ends up being 1/2. We see that k ends up being a negative 1/2, which means that our vertex now is the point 1/2 negative 1/2, or 0.5 negative 0.5. And so our y-intercept, of course, we just let x equal 0. So when we let x equal 0 and plug it into this term and that term, they both go to 0, and all we have left is a negative 1. So we see that we use our 2 points, 1/2, negative 1/2, and our point 0, negative 1, we'll have the graph that we need. And so from that, we also know that our domain is always all real numbers for quadratic functions, unless otherwise stated. And our range, since this is a maximum point on the graph, our y-coordinate will be the highest point. So we'll go ahead and go from negative infinity on to negative 1 with the bracket. Don't know why it's doing that, but yep, so sorry here. Shouldn't have put 1/2. I should have put negative 0.5, because our vertex, not the y-intercept, is our place where we have the maximum y value there. So that's fine. And then our function will be increasing on the first half. That means everywhere from negative infinity on to a positive 1/2. So negative infinity on to a positive 0.5. And then our function is decreasing on 0.5 all the way to infinity. So this concludes this particular video on using quadratic function properties, the vertex and axis of symmetry, to graph quadratic functions.